After that, there are also loops and conditional statements in the C language, which are also called as control flow statements in C, in which in loops there are while, do while, and for loops, and the conditional statements are if, else, and switch. And in the arrays section, the C uses arrays of characters to represent strings. Then again, the strings is the a new concept in C. After the strings, there is a pointers concept in the C, which provides a way to manipulate memory directly through pointers. Pointers are nothing but the variables that store the memory address of the other variables. Then the function in C. Functions are a block of code that can be called from other parts of the program and can return a value. There are two types of functions: library functions and user defined functions. Library functions, which are built-in functions in C language, and user defined functions means user make their own function and use it whenever he needs it. So after that, I learnt about the introduction of C++ language, which is an extension of the C programming language, and it is also the widely used programming languages in the world. So in C++, I have learnt about the means common or basic concepts in C++ and its applications in programming, making creating operating systems, embedded systems, and games also. So here are the fundamentals of the C programming which I learned in the during the internship. Then the next part comes with the introduction of Arduino, or what we can say. I learned all about Arduino, why Arduino is used, what is Arduino. So Arduino is work as a microprocessor, and it consists of a microcontroller. Uh, it is an open source physical device. Open source means everyone can code and set a particular function in the Arduino as they needs. Means if in it has an ever environment which is used to develop a particular function and write code on the software as Arduino IDE. Everyone can write code and edit the function on the Arduino. It is used to design and build devices that will interact with the real world. We will be using Arduino Uno board for our project as given in the internship. So Arduino boards consists of microcontroller, input or output, and a simple power supply circuit. It needs 5 volt plus 5 volt voltage supply. The microcontroller on the board is programmed using a simple and accessible programming language such as C and C++. It is based on the C and C++. So after the Arduino, we will be move to the our project. The projects are garden lights control, temperature control system, and water tank inlet and outlet valve control. So in garden lights control, we are controlling the garden lights means according to the brightness of the sunlight. Means LEDs are off while there is a daytime, and it will automatically turn on when there is no sun and there is dark, means atmosphere is getting dawn. So in temperature control system, we first measure what is the room temperature, means the temperature around the uh, room, and it will be displayed on the mobile screen as well as on it CLCD, and therefore if the temperature is higher, then cooler will automatically turn on, and if the temperature is lower, then the heater will automatically turn on. And in water tank inlet and outlet valve control, if the water level inside the cereal tank is goes to the highest value, then it will automatically turn off the inlet. And if we want to outlet the water inside the tank, then automatically we can uh, decrease the particular level and stops the uh, water level. So what tools we are using in this project? First one is Arduino IDE interface for writing code, Pixing Black for interface for the inputs and outputs, and third one is virtual serial port for creating virtual port for connecting all the components, and last one is Bink mobile app, which is a mobile application for controlling our devices. So what components we have used? Firstly, we have used LCD I2C, and it is 16 into 2, that means it contains 16 columns and 2 rows. In one row it contains 16 characters, in second row it contains 16 character also. Then we have used Ethernet shield for internet connection to the Arduino. Then we have used LDR, which is light dependent resistance. Other one is a temperature sensor for control of cooler, heater, as well as displaying temperature on the CLCD. And last one is LEDs as garden light control. So moving back to the our project's first requirement is garden lights. In this module, we have used the LDR sensor, which is light dependent resistor, which is used for the in measuring the intensity of sunlight. If the intensity of sunlight is higher, then it will provide more resistance and it will turn off the garden lights. Whereas the if the brightness of the sun is 0 at night times, then it will provide less resistance and the garden lights will turn on automatically. Arduino adjusts the brightness of the light as per the signal received. LDR sensor sends the signal to the Arduino from the surroundings, and here the range of value of analog signal is from 0 to 5 volt. This sensor sends this signal. The step size is equal to 5 by 1024 is equal to 4.9 millivolt. Maximum value of the step size is equal to 4.9 millivolt. The reading of output voltage from temperature sensor is directly converted into degree Celsius. So analog read function we will be used to read the average voltages. So we have used analog read function here. Then coming back to the next module is temperature control system. In this module we have used a LM35 sensor, which is used to detect the temperature in the environment and get analog input, which is used in controlling the temperature. For the remote control of heater and cooler, we have used a blink application, and the temperature is displayed on the LCD as well as on a blink application. So this is how the module works. Is first it a temperature system. um, the sensor present in the temperature system sends an input to the Arduino about the temperature readings. Then Arduino sends the temperature values and display it on the Blink app as well as on LCD in this module. And if the temperature is higher than the we have set the value to the 35 degrees Celsius. If the temperature is higher than the 35 degree, then heater will automatically get off, and the if the cooler is turned on, and the notifications of the temperature is if the heater is off or heater is turned off automatically, then immediately the notification comes in the display of the blink application. For the exchange of data between blink and Arduino, we have created the data streams which will be act as virtual switches. And in this module, the V1 pin is for temperature display, while virtual pins V0 and V2 are for cooler and heater respectively. So our third module is water tank control. uh, so for the virtual serial tank, we have used tool serial remote tank in Pixim Lab, and virtual ports are created by using software named serial tank to Pixim Lab. The inlet and outlet valve is controlled by using serial function serial.write. Virtual pin V3 is used as displaying amount of water in the present in the tank. V4 used for inlet, and V5 virtual pin is used for the outlet to turn it on or off. The volume of the water will be displayed on the LCD as well as on the mobile screen. So this is the model of the project. So for water tank, the sensor is present in it, so it sends the value for a the change of intervals of time to the Arduino Uno. Then it will be displayed on the LCD and blink application also. As for if the value is reaches to the particular value, suppose we have put the values as maximum as 3000, then the inlet valve is turned off. And if the tank is reaches the volume of the water tank reaches the below value than the set value, then it will turn on automatically. Now we will have a look at the coding of the project. So we have defined the various functions which are used in the coding. First one is cooler vpin. So if the value of the temperature reaches to the lowest value, as we have used here parameter as instant function. So it if it reaches to the maximum value, then the cooler gets off on, and the notification is printed on the LCD as well as on blink app. And if the value is below this set value, then it will turn off the cooler. Similarly, in case of heater, we have set a particular value of temperature, suppose at 35 degrees Celsius. Then if the value is less than the parameter value, then a heater will turn on, and it will print the heater on notification on the LCD. And if the value is at 35 degrees Celsius, then it will turn off the heater automatically. So for inlet value also, we have used the parameter as instant function, and outlet value also the same function is used. For updating the temperature reading, uh, there is also we have used a gauge in the blink IoT app for displaying temperature values